Hi. Is jump starting bad for your car battery, or electronics? Time to answer this question once and for all, courtesy of Electrofern. I kid you not, out of all the people I know that claim to know how to use jumper cables, only a small percentage actually know of all the dangers that can happen. In this video, I am going to teach you how to do it right without destroying your vehicle. You will also learn why this works and why to avoid the wrong method of jump starting. Hey, are you still awake? Let's start the conversation with jumper cables. You know, those cables you have in the back of your car. If you don't have them, you should go get some, just in case, right? Moving forward, let's briefly talk about gauges. Gauge is the thickness of the battery wire. A low number is thicker. Most jumper cables are either 2, 4, or 6 gauge. Notice the image on the left shows amps above the gauge numbers. This is the current's maximum rating. Cables. Resistance play a big role in how the system functions while jump starting. By multiplying this resistivity value by the length of the jumper cables and then dividing by the area of the jumper cables, we will find a resistance value to use for our.
Now, resistivity is a characteristic property that all materials have. It is useful in comparing various materials on the basis of their ability to choose electric currents. Okay, so the two materials of interest are copper and aluminum, and each will have its own resistivity value, where aluminum's value is 50% greater than copper's. But later, you'll notice that roughly 59% greater than copper. And high resistivity means high resistance, and a lower resistivity means a lower resistance. Now, once you know the gauge, you practically know the cross-sectional area of the wire. Most jumper cables are either 2, 4, or even 6 gauge, and we're choosing to choose the 6 gauge wire today. So, our value to use of area is 13.29 millimeters squared. Now, we know that resistivity is equal to 2.7 times 10 to the power of negative 8 meter ohms. And we're going to choose the 6 gauge thickness of the wire for now. This means a rating of 55 amps. This also means cross-sectional area is 13.29 millimeters squared. Now, let's assume the jumper wires is 25 feet. This means 7.62 meters. Okay? And after doing calculations, aluminum jumper cables produce about 15.5 milliohms of resistance. How clever. Oh, but let's do the same thing with copper. Resistivity is 1.7 times 10 to the negative 8. So, everything else remains the same. So copper ends up having 9.75 milliohms. How clever. Now, here are our results. Aluminum is at least half times greater than copper in resistance, just as expected. Ladies and gentlemen, let's get to the chase. Your battery's to your right, their battery's to the left. You just met them at the parking lot of Winco, and they're super sketch, and they keep telling you, oh, hey, I'm a mechanic, I know what I'm doing. And you're like, no seas baboso. How do I know you're doing this right? Well, here's the thing. What do you think they're doing wrong here? And what are you doing wrong letting the stranger touch your battery? Both batteries are now theoretically in parallel thanks to this scrutiny sucker. Unless you're trying to double your battery's amp hour stores, this is almost always a bad idea. Problem is, the voltages are not the same. As a result, their battery is charging your battery is charging their battery. Electricity is running around both batteries as fast as it can, and it's causing a lot of heat and a load of shit and stress. Fire, sparks, you name it, wind, anything goes. Acid in your face? Does that bring back memories? No. In reality, the batteries are technically non-parallel to each other. Might as well say it. In the real world, everything has resistance. Even those jumper cables you're using to get your vehicle jumps. Just like the way you got jumped in the alleyway. So you have negative to negative. Big deal, right? But look carefully at the schematic above. I have simulated the schematic for the aluminum jumpers. Notice how the current passing through either middle resistor is above 100,000 amps. In fact, the simulation is reading about 187,000. This is just a simulation, right? Of course, it's possible that the model isn't at all correct. However, this is a powerful comparison to this schematic. We're not doing negative to negative, we're doing negative some part of your car's engine. Notice that the current running through either middle resistor is no more than 11 amps. See the difference? I went outside to measure the resistance from the negative terminal of my car's battery to the engine. It was about 0.5 ohms. And this is important. It's this extra resistance between my car's negative terminal and their terminal that allows my battery to be safe. We need this extra resistance. This is why we connect negative to ground. Ground being practically anywhere away from directly to the battery. Now, here's the same simulation, but on the copper jumper wires. 297,000 amps. 197K. Negative to negative, pole to pole, bad wiring. The person that put this simulation together isn't reading his owner's manual on how to jumpstart a vehicle safely and properly. What a shame. Now, here's the same simulation for the copper wires, except we are now dealing with a properly wired system. That is hot. Negative to ground. Ground being at the engine block. Ay, ay, ay. Ooh, caliente, caliente. This shit's about to hit the fan. Instructions unclear. Look, here's the difference between aluminum and copper in regards to currents on a badly wired system. I doubt they sell 100% aluminum jumper cables, or do they? Well, actually, not really. It ends up the aluminum jumper cables are actually made from copper-clad aluminum. Whatever the hell that is, but it also ends up that the resistance calculations don't fall far from the tree. Therefore, whatever. For simplicity, just call it aluminum, or not 100% copper. Anyways, observe the damages above. If you decide to skip the negative to ground and do negative to negative like a bozo, you're gonna run into some nasty shit. Yeah, that kid left the A is kilo. To kill your engine. Battery. 187,000 amps versus 297,000 amps. Choose your poison. According to my theoretical model. So yes, copper's great. It's great at a lot of things, even killing your battery, it seems. And even at destroying your stuff if you use it wrong. If my goal was to destroy my car as fast as possible, I would probably offer the copper jumper cables and just do it wrong. Like, why not, right? Now, this video has been running long enough. Let's get to the point. That's probably what you're thinking, right? Nah, that's what I'm thinking too. I'd rather be asleep right now, but too excited. But, here's not a graph depicting the wrong jumper wiring. Interestingly, look what it suggests. Wow, so 440,000 is greater than 55 amps. What the hell is that face next to the amps? In the bottom right corner, what the hell is that? Is that a fish or what? Oh man, it's giving me allergies. But number two, the deader the redder. Essentially, if your battery is super dead at 0 volts, 1 volt, 2 volt, whatever, you're gonna run a greater risk of damage to the battery. Notice the graph. As at the very x-axis, as voltage increases, current decreases, mind the negative. It's not supposed to be there, but yeah, this is a really interesting fact. Now, here's what the current looks like when you are jumping correctly. Notice the difference in the big fat smiley face and old creepy picture? These values are easily handled by your jumper wires without any trouble. Great. Freaking. Now pause the video if you'd like to see the differences a little more clearly. When you're jumping your vehicle correctly, you'll find values like these. Wow, both shitty and good jumper cables theoretically perform the fucking same. Now that's incredible. Now, you just want to get straight to the point, don't you? Alright, well here's a quick diagram as to how to correctly jump your vehicle. And I'm too lazy to make my own diagram, so here you go. Notice how steps 1 is saying that you couldn't have just looked on the internet to just find out what the answer was. And steps 3 and 4 are going to negative. Check it out. In this case, we're ditching that whole idea. We're actually connecting negative to ground. Ground meaning on some piece of metal away from the dead battery, negative terminal. If I haven't said it enough times, I'm sure by now you'll remember negative to ground. Well, lad, with so much bare metal ready to help you stir some goodness, how the hell do you know where to connect the damn negative cable? You cannot screw this up, my friend. I believe in you. Where do I put it? Anywhere but the negative terminal of the battery, eh? Yeah, you see, there's also this big, huge piece of shit in your vehicle. It's called the engine block. It's a perfect place to get enough resistance to keep your vehicle safe. And the question arises, how far is too far from the battery to connect negative? And don't you worry, I got you, fam. I got you. I got a really fat graph coming. Okay, so check it out. At 0.1 ohms resistance between the place you chose to be ground and the negative terminal of your battery, you're still going to deal with some heavy shit. So, in fact, when you choose to place the negative terminal or where, it truly matters. Now, let's sweep the resistance of the engine from 0.1 to 1 with a step of 0.1 ohms, and let's go ahead and test this bad boy and see what we can find. I made this image bigger to make it easier to see. The very top diagonal line is the 0.1 ohm resistance found in the previous slide. If you're too close to the battery, you need to find a farther location. And therefore, you start seeing your results corresponding to the lower lines. Now the lines below are increasing in distance from the battery, and I would feel much safer picking a good balance between each. And number 1, my battery isn't too dead, and number 2, I'm pretty far from the battery. Friends, this is why we chose to clip the negative jumper cable to the engine. Remember, the arbitrary jumper cables we chose to analyze today only takes 55 amps of current max. We have to try not to go above 55. Better yet, stay as far as possible to ensure they don't die early. That's how it works. Alas, this is the current you get when clipping negatives to the engine. You finally learned how to do this properly. I'm proud of you. I know this is exactly what we're looking at because I know for a fact that it's 0.5 ohms from the engine to the negative terminal. I know this because I physically went out to my car like a dumbass and checked resistance myself because I was that dedicated to this video. From negative terminal to engine, 0.5 ohms. This resistance gives this exact plot of current, and notice how this is excellent, and it falls within our specifications of 55 amps. This is genius. Well, now you know. Why jumping incorrectly can damage your car, your cables, your battery, your hamster, your guinea pig, your life, your job, your wife, everything, man. You need that car, and it's hot, it's 2022, global warming. Why would you want to screw your car up? And that's why jumping correctly will ensure your vehicle is safe.